So hello everyone, and welcome to today's event. It's gonna be an introduction to game development with HTML5 with Christina today. My name is Slim. I'm the education team manager at Social Hackers Academy. And at Social Hackers Academy, so we started the school back in 2017. We started with the offline mode. And with the pandemic, we switched to the online, fully online courses, and it's going pretty well. So we have a wider reach in terms of having more students from the vulnerable group of people that we offer scholarships to. So which are the refugees, asylum seekers, and migrants mainly. We reached our 19th cohort. It's starting next week. And we're thrilled today to have Christina to present this very interesting topic. So hi Christina, and thank you for joining us today.
Hi, hello everyone. Thanks for inviting me. I guess I'll get started. My name is Christina, and I'm a programming teacher at Codigo, which is a boot camp in Lisbon, Portugal. And I'm here today to talk to you guys about game development in the browser. So I'm just gonna get started.
Yes, just one thing before you start, Christina. So if you have any question through the presentation, just write it down in the Q&A, please. Not in the chat because it go messy there. So in the Q&A, and we will Christina will answer the question as we go. Okay. Thank you, Christina.
Thank you. All right. So what is the canvas element that we're going to be talking about today? So like it says in the title, it's an HTML5 element, which means that it's completely native to the browser. You don't need to import any special libraries or any special packages to be able to begin to use it. And it's something that allows you to draw graphics and create animations using JavaScript, which is really interesting to be able to do things like creating, let me just get here, generative art using this kind of logic with fractal curving. It's cool to be able to do also another example I brought here of generative art using the canvas. It's very beautiful. Physics simulations, like here we have a little moving cloth simulator, which is used with JavaScript, and also fully image graphics. What we have here is a single image, and then we have a method here that's called color cycling. So instead of us having several frames that are being run through, it's a single image, and then they're changing the pixel colors to make it look like the waves are moving. None of this was me who made it, by the way. All of these links will be on a public GitHub repository that I'm going to share at the end. That's going to have links to all of these things, and also the code that I'm going to be making today, as well as some assets that you guys can use to emulate the game that we're going to be doing. So yeah, you can do a bunch of really cool graphics, and finally you can also make games. So the game that we're going to be doing today, let me get it running. It's very, very simple. It's going to be a little clone of the Chrome dinosaur that you get when you don't have internet. And what do we need to do to make this kind of game within the hour? Well, okay, we're going to need to have a side-scrolling background. I need to have this little guy with his wonky little feet animating through a cycle. We want to be able to keep score when we can jump over the cactuses. We want to have a high score to motivate you to keep trying over and over again. And we're also going to have a game over mode. And then by the end of this, I'll show you guys also how you can upload your mini games onto a platform like itch.io, which is a place where you can do indie game development. And it's super, super easy. And then you can just send links to your friends so they can play your games in like 5 minutes. All right, so let's get started then. So in order to start using this really, really simple API, you're going to need an HTML page. And you're going to need to create the canvas element. And you do so like this. It's simply just called canvas, and there you have it. It's done. I've given it an ID because you can actually have more than one canvas element. You can do a sort of layering. So you could have one canvas element to have your background, another canvas element to have the foreground with your characters running on it. So it's a good idea to give it an ID so it's easily grabbable in JavaScript. And with just this, if I run this in the browser, ta-da, looks amazing, right? There's nothing there. But if I open up my developer tools and inspect, I can see that I already have my little canvas element in the screen. The thing is, it starts off transparent, so you don't really see it. It also already begins with a default width and a height of 300 by 150 pixels. But since it's already present, I can now use JavaScript to grab this element from the DOM and start manipulating it. So that's what I'm going to do. I'm going to leave the DevTools open for a second. Go into a file, index.js, and let's grab this element. Get element by ID. I called it canvas because I'm not very creative. And now we can do things like change the width and the height. 500. Save it. Take another look. And okay, yeah, it's working. At least our files are definitely imported right. And I can see that I've already started to make changes to this canvas element. But I don't want to be inspecting or seeing this element by my dev tools. I want it to be visual. So I need to actually give it a background color. So the way that this works is you grab your element from the DOM like so, and then you can do typical manipulations you can do with any kind of HTML element. But if I want to be able to start painting onto the canvas, then what I need to do is I need to use syntax like this. Canvas.getContext 2D. Now what this does is it gives you an object that has a bunch of functions that are going to let you actually do things to the canvas. So it's going to be through this variable, CTX, that I'm actually going to be doing paintings. I'm going to be making rectangles. I could do text. You can make circles. You can make any kind of shape, really, with this API. It's really, really simple, the API. Like, it's just lines, rectangles, circles, and images. And then you can make those images and circles and lines move around by manipulating where they're being drawn on the canvas. But that's really all you need to make any kind of game. Any kind of game you can think of, it's just like a couple of shapes that are moving around, and then there's some programmer logic that's going on behind the scenes. So let's change the background color. And the way that we do that is we're going to use something called fill style. Now, this can take any CSS color that's you can normally use. It can take an hexadecimal color. It can also take an RGBA. So I'm just going to color it white. If I do this, nothing happens. And now I'm going to say, OK, context, time to actually paint something white. What do I want to paint? In this case, I want to paint a rectangle, and I'm going to use fill rect to do that. And what fill rect does is it expects 4 different arguments, one for the X axis, one for the Y axis, and then what is the width of this rectangle going to be, and what is the height. So I'm just going to put some values here, and then we're going to talk a little bit about this X and Y and these pixels. So I'm going to start from 0, 0, and I want it to be as wide as my canvas actually is, and also as high as my canvas actually is. Okay, now we have something. We have a white rectangle. And just in case, because I'm not sure how familiar everyone else is with this, so we'll just talk about this real quick. So this business with the X and Y axis is the X axis is going to be, let me just get this ready. From this point all the way across here, it's your basically horizontal plane. And then your Y axis is going to be your vertical plane, okay? And the way that it starts with Canvas is this very uppermost left corner is going to start at 0, 0. So this line over here is X and Y 0, 0. And it's going all the way over to 1000 pixels on this side, because I said that's the width I wanted it to have, and 500 pixels down here. So what does that mean? If I now want to draw a rectangle somewhere on this screen, like over here, for instance, I'm going to want to say, well, I want it to be, you know, like 20 pixels over to the right, and I want it to be like 10 pixels down or whatever. And then I'll say it's going to be 50 by 50 pixels to make a cute little rectangle. And then if I want to make this rectangle move from this place over here, all I actually have to do is manipulate these values over here. In this case, since it's a movement horizontally, I only actually need to manipulate this value, the X value. And the way that I'll be manipulating it, since I'm increasing from 20 over to this side, will be something as simple as like an X++. If I wanted it to go down, I'll be increasing the Y. If I want it to go up, in this case, I'm decreasing it. I'm decreasing the Y. And if I want it to go to the left, I'll be decreasing the X values. Okay? All right, so let's get a little red rectangle here on the screen, make it move, and then we'll get started with our little dinosaur game. All right, so the thing is, if I now start to say, okay, now let's make another little rectangle over 20 pixels across, 30 pixels down, it's going to be 50 by 50 pixels. What happens is any shape or lines or circles or whatever I draw on the canvas is going to assume the last color that I set, which in this case is white. So it's just going to draw another white rectangle, and we're not going to be able to see it. So it's important that you guys remember that anytime you want to create something new on the canvas and you want it to look different, then you need to set that color. So let's make a red rectangle. Whoops. There we go. And now, since I've already set the style to red, I can create a bunch of different rectangles. So this is going to be 50 across. This is going to be 90 across. That could be 20 across. I don't have to reset the color anymore because now they all know, well, now they're all stuck between each other. Need to give bigger values. 500 across. You can be 800 across. There we go. So you set the color, you create the amount of shapes that you want to do that's going to adopt that color, and then if you want something else to have a different color, you need to remember to do fill style again. Okay, let's get this shape moving across the screen. How can we do that? Well, I don't want to use like a loop, like a for loop, and say 20 times move to the right, because I'm not going to actually visualize that, right? By the time I actually see it, it's just going to teleport to the area that I say. It's not going to look like a smooth animation. We don't want to use a while loop because that's going to break the browser, right? JavaScript is single threaded, so that's not going to work. We have something like set interval that could work, but I don't have to say exactly how many times I'm hoping to do it in. And I don't really know how many times I want to refresh it. It could also depend on the browser that the person is using, right? So I'm going to use something that also comes with the browser that maybe you guys have already heard of, which is the request animation frame. And it's really cool because request animation frame is a method that receives a callback function that it will call before the browser does the next repaint. And normally it will be called at around 60 frames per second, but it will adjust that depending on the browser that the person is using. And it has little optimizations, like if I'm no longer looking, like if I move away and look at something else, then the animation pauses, which is the case of this one here. Like if I move away and then go back, it basically continues on from where it last is. So that will save on battery life of computers. So we're going to use that. That's going to be pretty cool. I'm just going to use for the one rectangle. I'm going to create an animate function then, and a variable x that starts at 10, for instance, and put you in my animate. And since the x coordinate is the part that's going to be updated, the part that changes, I'll put the variable in here. I'll do x++, and then I'm going to call request animation frame animate. Now the reason why I have to do it inside animate is because request an animation frame is a one-shot method, so it will be called once and then it stops. So I want to make sure I'm doing this recursively, so I'll call animate within whatever the next browser repaint is going to be. It will run this, and then it will basically schedule the next animation call. Okay. Let's see, shall we? Oh, where'd it go? Ah. I have to call the method for the first time, otherwise nothing works. Okay. It's not quite what we wanted, right? It would work if we were making a snake game and we wanted to have this kind of dragging sort of animation, but it's not what I wanted. I wanted it to be a square that's moving slowly from one edge to the next. So what's the problem here? It's painting a new rectangle each frame, but it's not deleting the previous rectangle. So we're just seeing everything. So there's a couple of ways that we can handle this. The canvas has a method called clear Rect, where I can say, I want to clear everything from this point to this point. The problem is if I do that, it's also going to remove the white background and it will just make it transparent again. So the way that I'm actually going to do this here, instead of me clearing everything that's on the screen, I'll just take these two lines over here, pop them in here. And that way, what I'm constantly doing is I'm going to paint the canvas white, put the rectangle in a certain position, the next frame, paint the canvas white, put the rectangle in the next position. And we have animation. And now I can see that I have a screen here that's showing me what you guys are seeing, and it looks a little bit like jaggy sometimes or pixelated, but that's a connection issue because over on this side, it's really smooth. This is basically all we need now to make our game. Like, what else do we need to know? This is it. I know how to create a shape and I know how to make it move. And then I just need to write some JavaScript logic. Okay, what happens when it reaches a certain position? Let's get cracking. And let's start with making a side-scrolling background. So we can also make images with the canvas elements. We could do something like image equals a new image, create another HTML5 element, change the source. Well, I don't want to be creating new images constantly, but we could change the source to, let's put this outside here. Okay. Give it a string source. I have here some pixel art that I made. I mean, it's a ripoff from the game, but you guys are free to use it. We'll grab our little dinos over here. Resources, dino.png. All right. And then ask the context, hey, let's draw this image and let's draw it. And then we say, what's the X and the Y coordinate of this image going to be? So let's put it 50 pixels across, 200 pixels down, for instance. And where are you at? Ah, so let me, let's not draw, let's draw image. There he is. All right, so draw image, 3 arguments. The image object that already has the image loaded, and then where on the canvas do we want to paint this image?
Christina, we have a question. Sorry for interrupting.
No, no problem.
Okay, so Dionysus is asking, actually, it creates a white canvas with a red rectangle over the old white canvas with the old white rectangle.
Yes.
All right.
Exactly. Okay, so how are we going to do a side-scrolling background? Right, let me see if I still have the finished product. So this is an infinite runner type of game. So hypothetically, if you're really good at this game, I'm not, but if you're really good at this game, you could just go on this forever, right? So you need to have a background that can also run forever. So you could have, I guess, a super, super, super long image, but it's not going to be infinite. Or you could do what we're going to do, which is, in my case, I have actually quite a small image. Ground PNG is just this size. So it's not going to actually run long enough within the size of our canvas element, since it's already 1,000 pixels wide. As soon as I take this image and start to move it to the left, you're going to notice that there's going to be no more background after a while. So what I'm actually going to do is I'm going to stack 2 images side by side, okay? And the way this works is, think of the canvas as being a sort of viewport, and all of the other things that we can draw aren't quite visible yet. So we have our viewport here, our canvas. In this case, it can be 600 pixels wide. And I'm going to have my ground image instantiated twice, basically. I'm going to have 2 images, the exact same images side by side. And then what I'm going to do is every update, I'm going to draw those images in a new position. So I'm going to be manipulating the X coordinate in this case. And since I want it to look like my character is running forward, then I need to make my background move to the left. So it's going to be decrementing in this case. It's going to go from pixel 0 to -1 to -2 to -3, etc. So it'll start moving during the update. And eventually it's going to get to this point. Now, if our image moves any more to the left, you're going to see that there's no more background, right? It's going to run out. So I need to have some kind of logic here where when the very, very tip of my image has reached negative its own width, then what do I need to do? On the next update, I need to reset it, basically put it back to the beginning. And then it's just going to continue on from the beginning. It's just going to keep going like this. Once my image X has reached negative its own width, reset back to the beginning. And if you use images, you can do that. You can do like an inverted image, for instance. You do need to be careful, obviously, to make sure that the way that your image ends makes sense for how the next image begins, for instance. You could also just use a very big image. Like this could be one big image. And simply I see when this edge or when this side has reached my canvas width, then I need to reset it, okay? In my case, my ground at the beginning here is pretty much the same as the ground at the end here. They feed into each other well. So you're not going to notice that there's any cut going on. Okay. So I've already have some things pre-made here to make this quicker. I have a little background class. And my background class is going to receive, when I create it, the X and the Y, as well as the image source, basically. Change this name. It's not quite an image yet, it's the image source. Okay. what I have here is I have two methods. There's absolutely no need to organize your code like this, but I just like doing it this way. I have an update function, and then I have a private draw function. And the update function will call the draw function on every loop. I just separate it like this because I like to have all of the logic of drawing stuff and painting images in one place, and all of the like programmery logic, the ifs and checks and stuff like that in another function. But there's no need to do it this way. So when I call the update, I'm going to pass the context option just so I don't have to import it in every single file. So I just pass it through methods from one area to the next. And I'll give it to my draw function. I have here this check, which will see, okay, when my x coordinate is less than or equal to my negative width, just like I was showcasing in that little drawing, let's reset the x. And then what does our draw function do? Well, it's going to draw two images. The source for the image is exactly the same. They're two duplicates. One is going to start in the beginning on the 0 point, and the other one is going to start at the 0 point plus the width of its image. So they're going to be stacked side by side horizontally. And then I have this little variable that I will be receiving in my update called dx. You might see dx a lot of times. It means like derivative of x. It comes from math. Basically, you see it being used to represent like some kind of variable that's going to change the value of x. So it could be like game speed, for instance, and that's what I'm using it for. I'm using it for velocity. You could also be using it for gravity and stuff like that. But yeah, so I'm going to be adding some kind of speed onto it. In my case, since I want it to go to the left, I want it to decrement, but that's fine because I'll just pass it a negative speed. If you add a negative to something, then it's going to be decremented anyway. Everything good here so far? I don't know if we got any questions or if I can continue.
I think you can. We don't have any questions. Seems like
Okay.
Everything is clear.
All right, cool. Okay, so let's go over here and let's make some backgrounds. Let's import background from classes, background.js. Right here, DOM elements. I'm actually not use this here anymore. And this can stay for now. Actually, I don't have any of you guys. And let's have our objects here. Let's background, these are all the new background. X and Y. So X start at 0. Y, I'm not sure yet. Let's see what looks good. Possibly 300 pixels. We're 500 pixels wide. High. Image source is going to be in resources dot /ground.png. Okay. And then we want to remember at every loop, we want to update our background. I'm going to give it a reference to our context and also a value here, which is going to be for the beginning. We'll try -25. We'll see if that's too fast. It might be a bit insane. And I think we can give it a test. Nope, that's the end result. Okay, pretty fast. But okay, we have movement. It's moving pretty smooth over here. Let me slow it down a little bit. It kind of hurts to look at. Let's see, -10. Okay, that looks better. That looks good. I see some stuttering on the Zoom meeting, but it's looking pretty good over here. And just so we don't have this magic number over here, I'm gonna create a some constants. Create a game speed variable that will equal to 10. Because I'm going to be using the same value for those little cactuses that go along. I want them to be going at the same speed as my background. So I'll have this in a little variable and have a negative game speed. Okay,
And I
Cool.
think, Christina, this answers another question that we have in the Q&A. So
Yeah.
Dimitrios was asking, before you call the background.update function in this file, he asked in update function arguments from where we destructure the variables. So
yeah, this is also something that's unnecessary, but because I don't like sometimes seeing these kind of magic numbers showing around, I kind of like to do it like this, where I pass an object and then I give meaning to the arguments that I'm passing. But I mean, you could just pass directly the arguments if you wanted. You could just pass game speed there.
So when we call the function in this file, Dimitrios, that's where you give it the arguments, actually. So I hope this answers your question, and I think we can move on, Christina. Thank you.
All right. Okay, so now I think the next step would be for us to put a very simple player object. And for now, he'll start off as a little red square. And we're just going to make him jump. Okay, and we'll see what the logic for making the little rectangle jump is before we turn him into a fully fledged dinosaur. So for that, I have another little class that I've already made. So in this case, he's got a little constructor, he gets an X and a Y value, and he's going to also create a property, which in this case is going to have a dy, the Y velocity, because in the case of our player, he doesn't actually move from his position. He's always in the same spot, except for when we hit the space bar, when we want to make him jump up. So in that case, the only thing that is being modified is his Y axis, not his X axis. So we're going to have him be a little blue rectangle. And I have these two methods that we need to implement, which is jump and crouch. Crouch we won't actually be implementing this time, but I'll leave it here if you guys want to then add on to this game and add some extra features. And then our update, we're just receiving for now our context object and adding on our dy. Since dy in the beginning starts at 0, it's actually not going to make any difference whatsoever to the y-axis at first. Okay, so let's import this dinosaur. Import dino from dino.js. Okay, have them over here with my other game objects. Okay, where do I want him to be? I can try 10. Kind of want him to start around the same place where my background is, if that makes any sense. And, oh, he's not an image yet, so we don't need to pass this. Let's just see if this is any good. And then after we've done our background, we'll draw a little dinosaur. Again, here I could just pass this directly, but since I know later on I'm going to be adding some more stuff, I've already left it as an object destructuring syntax. Okay, so cute little blue square, not doing a whole lot of nothing right now. To make him interactable, we need to play around with some event listeners in JavaScript, right? We need to say, hey, when somebody clicks on the spacebar, then I want him to do something like jump in the air. And hey, maybe if somebody presses the arrow down key, then I want him to crouch, for instance. So for that, I've got a little directory here called utils. And I've made a little keyboard handler file. It's just to tidy away this whole logic of listening for events and stuff like that. So one way that I could do this, I'll just hide away this stuff. Okay. One way I could do this is inside my event listener, I could have something like a series of ifs, or I could have like a switch case to see, all right, if the key that was pressed is spacebar, then I want to invoke dino.jump. If what they pressed is arrow down, then I want to invoke dino.crouch. If they pressed R, then I want to refresh the game. If they pressed, escape, then I want to pause. So I can have all of that logic in here, right? But then I'd also need to have a reference to those objects in which I wanted to call the methods. So what I've done is I've got a little keys object up here, and this is going to hold all of the keyboard keys that I care about. And I have a function that I will be exporting. So this is function I'm going to be using here in my index.js. And what I'm going to pass here is a string that represents the key that I care about. And I'm going to write that string exactly the same way as I know I will be receiving it here. And I will be giving it a function. So in this case, I might call bind event, and I will pass space and dino.jump. And then I could call it again and pass arrow down and pass dino.crouch. What it's going to do is it's going to create a new object stored in here associated with that string. And all of the objects that are ever going to exist inside keys are all going to have exactly the same function. It's going to be called execute. And that means that I can call it in a very simple way down here in my event listener. What happens is when someone presses something like the F key, I'll receive the F key here, and I'm going to see, all right, do I have any property inside this object that is an F? If I don't, then it's not a key that Christina cares about, so we'll just leave this function. But if it does exist inside that object, then it is a valid key. And what do we want to do? Well, I want to grab whatever is associated to that key, and I want to execute its function. So let's see maybe how I'm going to put all of this together, and then hopefully that will answer maybe some questions that you guys might have. So also, because I don't like passing around strings from one place to the next, so I have a really, really simple object just called keys, and I associated the strings with a name that I can call easily from inside my index.js. So all of this is going to come together with, say, call this keyboard, each is a keyboard handler, and import keys from utils keys.js. And then I'm going to create a little init function. Totally unnecessary, just like to have things organized like this. And I'm going to say, okay, at the beginning of my game, let's bind some events. What event do I care about right now? I care about the space event. Cool. And if you care about the space event, then what do you want to happen when somebody clicks on the space? Well, in my case, I want him to jump in the air. We'll do the same thing for our crouch. Just leave that already set up. Okay, dino.crouch. And let's just put a console log in here so we can see if everything is set up correctly. I do love my console logs. Crouch. Okay. And we mustn't forget, let's call init. And let's test it out. Okay, so hitting the space bar. Whoa, I'm jumping 20 times. And now let's press arrow down, crouch. Okay, awesome. So this is all set up nicely. Now let's actually make something happen when he jumps. All right, so what do I need to do to make my dinosaur jump? I need to change the value of this property over here. And say, actually, you're not going to be 0 anymore. You're going to be, well, in our case, since we want to go up, right? And upwards is where 0 is. We want to actually decrement the value, right? We want to do y, I was going to say Portuguese stuff now, minus minus. There we go. So the way that we do that, when someone hits jump, then I'm going to say dy will become, well, yet again, we will test a number and see if it's too fast or too slow, it's too crazy, whatever. So let's see. Hitting space. Bye. Not much of a jump, but he's left the stratosphere. He's gone. Okay. So in order for this to actually work as a proper jump, what goes up must come down. So now we have to find a way to say, okay, once you've reached a certain jumping height, cool, now come back down, please. And the way that works in real life is it's gravity, right? Gravity is what pulls us down. So we kind of just need to implement some form of gravity over here as well. So let's define what the maximum height is going to be. This is also just going to be a number that you're going to fiddle about with. It's really going to depend also on how fast you're jumping up. You guys will see once we start putting in some cactuses, I will want to fiddle around with how fast he's going up, because I want to make sure he actually makes the cactus jump. I don't want it to be too short. Let's see. Okay, let's say it's going to be minus 80. There we go. So whatever his original position is, negative 80, goes a little bit up. And we'll make a property called gravity. And yet again, we'll fiddle around with this number, but I have fiddled around with it earlier, so I think 2 is going to be good for what I want. And here in our update function, we're going to see, all right, if this.y is less than because it's a negative number going up, right? So less than or equal to maximum height, we want him to stop going up. We don't want it to be like an abrupt thing, like, okay, you've reached maximum height, now you have to stop here. What we want to do is we want to say, okay, you can continue to decrement some numbers, but it's going to be less. And it's going to get less and less and less and less and less. And then eventually you're going to come back down. So we want it to be kind of like a smooth, gradual thing where you go up and then you slow down and then you come back down. So the way that we're going to do that is we're going to say that this.dy is going to have gravity applied to it. So right now this.dy is negative 20 and gravity is 2. So once it reaches the maximum height, then on each update we're going to be decrementing then 18, then minus 16, then minus 14, then minus 12, until we get to 0. And it stops, and then we'll be adding on 2, 4, 6, 8, and then it's going to come back down. All right, let's test this out. Okay, and I think if you look, you can see it doesn't feel super abrupt. It feels kind of like, you know, okay. But now we have the opposite problem where he's just falling into the ground. But we're getting there. So now we just need to make an invisible ground logic, right? So how do we know when we want him to stop and not go any further? Well, let's remember where we started. So we're going to keep our starting y. And then we'll just have another check here and see, okay, if our y is bigger than or equal to our starting y, because we're going down, so it's incrementing the value. Then what do we want to do? dy is equal to 0. And this.y is equal to this.starting y, just in case we fell a little bit further. We'll reset it to where he was initially. All right, let's see. There we go. We got a little jumping function. And if I keep jumping, okay.
He starts flying.
Yeah, we got Flappy Bird going on right now. Which is also, it could be something that you guys want. You could want to do like a Flappy Bird. And in this case, if you wanted to do a Flappy Bird, you wouldn't have a ground so much. You would say once he hits here, then it's game over, right? And then you would force the player to continue pressing space to get through the obstacles. but this isn't the kind of game we're trying to make. So I actually don't want it to be possible for you to make more than one jump. You can only make one jump at a time, because otherwise you could just fly over the cactuses. So the way that we're going to do that is with a very simple Boolean check. We'll have a property is jumping starts false. We're not jumping in the beginning. And then here we'll do a check. I only want to apply this if I'm not jumping. So we have the bang operator there. So if I'm not jumping already, then cool, we'll do this. And now I am jumping. And then we'll just reset that Boolean when we hit the ground again. So let's see. Okay, jump still works. And now I'm furiously hitting the space bar, and he's not flying up into the sky. All right, leave the code on the screen for a little bit. You guys can take a look. Okay, so what's missing now? What's the next step? Let's take a look. We have our player. He's starting a little bit high. We can adjust that in a little bit. He doesn't really look like the dinosaur that we imagined, right? And he can jump, but there's no real reason for me to jump because we don't have any obstacles on the screen yet. So I think maybe we should actually have our obstacles come into play here. Now, we can start off by doing rectangles. I really do recommend when you are making games, start off with really simple shapes just to see if they hit each other, if your game logic is working right before you throw in images. But we're going to jump straight to images over here. And the image that we're going to be using for our cactuses, well, we have two sets, because in the original game there's obstacles with lots of different shapes. You have big cactuses, tiny cactuses. You also have flying objects and stuff like that. So I have this sprite sheet, which is going to hold all of the tiny cactuses that I want to have in my game. And I also have a different sprite sheet over here, which just has 2 cactuses. I didn't have time to make more. But you should. It would be more interesting with more than 2. Now, here's the thing. If I just throw this image into the draw image function, then I'm going to get all 6 of these cactuses showing up on the screen. And I don't want that. I want to just grab one of these cactuses at a time. Now, what you could do is you could take this sprite sheet and you could cut it up into 6 individual frames, and then you have 6 different images, and you could put them in an array or something, and you could iterate over that array, and there you go. The thing is, in a game, there's so many images, right? The more and more files that you have, the less performant it can become. So sprite sheets are kind of a way to handle this by you only have one resource, one image file, and all of your images are on that image file. And then what you do is when you want to draw something, you say, let me draw a tiny portion of this image file, rather than let me load a whole new resource from my project. So the way that we're going to do that is with the draw image function. It can be used in 2 ways. You can use it the way that we've used it so far. So where is the background? Here, where it receives 3 arguments, the image that we want to show and the X and the Y coordinate. But it can also get 9 different arguments, which is optimal for using the sprite sheets. So let me just grab my pen for a second to show what I mean. All right, get rid of that. Okay, so what we want to do is we want to grab, for instance, just this portion of the image when we're going to create a new cactus. And then the next cactus that we're going to create on the screen will be the next image. In this case, they actually happen to be clones of each other, those first two. And then the next cactus will be this image, and so forth, and so forth, and so forth. Now, what we can pass to draw image is we can tell him, all right, I want you to start grabbing the image that begins, in this case, for this frame, at, whoop, don't want to use this, I want to use this, at x 0. So this one starts at 0. And then I have to say how wide this particular frame is. So in my case, this is a 306 wide file, and there are 6 frames. So it is, I'm not great at math, let me see, 51. All right, perfect. So each one of these frames is going to be exactly 51 pixels apart. Now it's really, really important that it is pixel exact. Like you have to be able to divide it by the amount of frames and it be exact. So be careful either when you're drawing sprite sheets or when you're grabbing sprite sheets free from online that you make sure that it is pixel perfect. So what I'm going to say is that let's grab the drawing that's from x0 up until pixel 51. And then the next frame will start at pixel 51 and goes up until 102, right? Because we're always adding this number. And then the next one will start at 102 and go on until 153, until we finally reach our final frame over here. Makes sense, right? So how are we going to do that with the function that we have? Let's see. Okay, so let me take some time here to explain what's going on. So I have created here a obstacle class, and then I have some subclasses because I just have different types of obstacles, and each of them have different number of frames, and they calculate the way that they frames a little differently. So my obstacle class will receive the X, the Y. How am I receiving it like this? There's no reason for me to receive it like this. Silly, silly me. There you go. It will receive the X, the Y, the image source, the number of frames for this particular sprite sheet, what is the total width of my original image, and what is the total height of my original image. Then I'm going to create an image, set the resource, and then I'm going to figure out what the width for an individual sprite is going to be. So the way that I do is I look at the total width of the image and I divide it by the number of frames, which is what we were doing. So it's going to be 51 pixels. The height is going to be the same because in the case of our sprite sheet, it's all just one row. We don't have several rows, so we're good there. And I'm also going to hang on to this number of frames. So I might do this. When I create, for instance, our tiny little cactus, what I'm doing here is I'm going to remember what the current frame is. It's 0. And it's a static one because every time I create a new object, I want them to be able to remember what the previous frame was. So it starts off at 0. It's going to create a property called this.frame with that value. So the first one is going to say, all right, I am frame number 0. I'm starting with 0. It's like 0 index of array. Doesn't have to be, but I'm going to start at 0 because it's actually going to be handy for me later on to start at 0. And then I calculate what the next frame is going to be. And this is just a very simple check. You know, I will increment it until I get to a point where I have reached 6, or in this case, I'm at number 5 since I'm starting at 0, right? So 6 total, 0 to 5. And then I'll see, okay, if I added a number here and it reaches the total number of frames that we have, then we got to start back from the beginning. We're going to reset and cycle from the beginning again. How are we going to use all of this together? Let's draw the image. I'm actually going to give an enter here since it's so many arguments. It receives the image that I want to draw. And now, stop it. And now it's going to receive what is the x coordinate of this individual sprite within this whole image that we have here, right? Let me see if this will have, you get the point. Come here. Okay, what is the x coordinate of this individual frame? And that's something that varies, right? It's going to start at 0, and then at 51, and then at 102, and then at 153. Or we could think of it as it's going to be the width times the current frame. So if current frame, width is always constant, right? It's 51. Current frame starts off at 0. Anything times by 0 is going to be 0. And then it's going to be 1. 1 times by 51 will give us this one. And it's going to be 2, and it's going to give us 102. So we're going to use that over here in this dot width times by, what do I call it, this dot frame. Y-axis is always the same in our case. It's always going to start at the top, 0. And then how big is this individual sprite going to be? And then it receives another 4 arguments. So these first arguments here is what in reference to the tiny image, the sub-image. And then the next arguments it receives is, and where on the canvas do you want to draw this tiny image? And it's going to say, well, I want to draw it on my X, my Y, and it's going to be also the same width and height. So this is a lot more extensive than the other one. But yeah, reference to an image, talking about the sub sprite, where on the canvas do we want to place this sprite? Okay, and I already have basically these 2 subclasses. They're very, very similar. They're very simple. I'm going to export them so that I can create randomly big cactuses or small cactuses. And rather than me have all of that logic in my main file saying like, okay, let's do a math random. And if the math random is smaller than 0.5, let's create a big cactus. Otherwise, we create a small cactus. And here are all the variables that they need to receive, and have that kind of polluting my main file. I have here a obstacle factory file, and I created a create an obstacle function. Basically, this is just going to encapsulate all of this messy logic hidden away in a very nicely named function. So when I want to create a random obstacle, I'll just say, I want it to be born on this X position and this Y position, and then it's going to do a very, very simple 50-50 probability and give me either the small cactuses or the big cactuses. And this is the function that I'm going to call in my main file. So let's import that. Import factory from classes obstacle factory. Cool. And let's create an array of obstacles. And for now, just to see if our factory method is working, let's just push something in there, factory.create an obstacle. Where do I want it to start? Well, I want it to start at the very edge of the screen. I don't want to see it initially I don't want them to like magically teleport on the screen. I'll say, okay, you're going to start on the very edge, canvas width, and let's see. I wanted it to be the same as the background, right? Okay, so I think it's a good time to put this magical number over here, starting height. height, 300. Let's pop these up here. All right. Starting height. And you will also begin at starting height. Okay, so in this case, it's just going to create one, either a big cactus or a small cactus, but it's just for us to test to make sure that everything is set up right. So, oh, and every time that we create an object, we mustn't forget to come down here into our animate and call the update. Since we have this in an array, let's call our for each. For every obstacle that we have, let's call this update function. And what is this getting? I think for now, it is just context and also the speed in which it's going to run. Okay. Context and the speed that it's going to run. It's going to be the same speed as the background. Negative also because they're moving to the left. All right. Where is it? What did I forget? Let's see. Create an obstacle, canvas width, starting height, sounds good. Resources, cactus, resources, big cactus. Let me try something here. How many people do we got here? We have like 20 pairs of debugging eyes. Hopefully someone will spot what I have done. Okay, let's say if they all start at 0.0 width, height, and they're going to begin at this X, Y. Okay. Why did I? So if I say in concrete, we'll start at 0. New. Oh. All right, console logs to the rescue. Let's go. Are you being created? If so, let me know. You are. Okay. Where are you being created, sir? So let me see. Am I drawing it? Okay. Okay, just checking that everything. Okay. All right. So interesting. This is being invoked totally wrong. Undefined and not a number. This isn't what I wanted. This.x is an object. Oh boy. All right. Let's see how this is being called. Wait a second. I deleted this, didn't I? It's because I'm calling it as an object elsewhere. Yay! Okay, well, sorry about that, guys.
You shouldn't have removed it from the very beginning.
Yeah. Okay. Yeah, because what happened is the way that I'm then calling this constructor elsewhere is I'm passing it as an object, and I forgot that I was doing it that way, so I shouldn't have removed the destructuring, or I shouldn't pass it as an object elsewhere. But okay, found the problem. So let's get back. All right. All right, where were we? Okay, so game runs. We have a big cactus, another big cactus. Okay, now we have some small cactuses. So the logic is working. Object creation is fine. The problem is it's just creating one and then it stops. So we're not really testing to see if our cycling through the sprite sheet thing is working. So what I want to do now is I want to create a logic of every 10 steps or every 100 steps or whatever, every X amount of interval, I want to create a new cactus. So let's go to our index file. Let's create a constant spawn interval, try 100. And I'm also going to create a spawn counter that starts at 0. And all I'm going to do is in my animate function, very beginning, I will increment the counter. And then I will do a little check. And I will see, okay, if spawn counter modulus, the interval, is a remainder of 0. So, you know, at 100 and then 200 and then 300 and then 400, what do I want to do? I'm going to put this, push a new obstacle into my array. So let's see if this works. Okay, got one cactus, small cactus, big cactus, big cactus. Okay, it's going good so far. Everything's great. Now, we do have some additional problems here. Well, one of them is a problem, one of them is not so much a problem, but it's just not very cool in terms of the game design. So right now my cactuses are spawning at the exact fixed rate between each other. So if I figure out when's the optimal time to jump, I could kind of just, like, I don't even have to look at the screen. I could just time it, right, perfectly. So it would be cool if it's a bit more of a, kind of more random, the interval between them. So when I say where I want it to start on the X, I want it to be definitely at least canvas.width. And then I'm just going to add a very simple math random times by 100. So some will start right on the edge of the width. Some will start on the edge of the width plus 50 or plus 90 or plus 20. We'll give a little bit more of a randomness between how they're being called. And now a big problem that we are actually having here is every 100 steps, we are creating a new object and popping it into an array, right? And then down here, we're going to be iterating over that array and asking all of them, please update, please update, please update. Now, this is an infinite runner. So theoretically, if you're a really good player, you could be playing this for like an hour. So we will have at that point literally thousands of objects being created, and we're going to be iterating over thousands of objects, and it's going to get bigger and bigger and bigger. And there's absolutely no need for that. Once the cactus has left the screen, I don't need to continue updating it. I don't need it to exist anymore. So yeah, what we're going to do is basically on each loop, we're going to filter through our array and just like remove any of the objects that don't need to be here anymore. So we're just going to do something very, very simple. Let's do, and that's why I made my array a let and not a const. So obstacles will be obstacles filter. Which are the cactuses that we want to allow to remain in our array? Well, any of the ones whose X plus their width is still greater than 0. And the reason why I did X plus width is because I don't want them to kind of blip out of the screen when they're halfway past us or something like that. I want it to seem as if they've gone off screen, then you're none the wiser about what happens to them. And we can test to see if this is working, right? We'll just print obstacles.length. So, okay, we have, it's not increasing anymore. We never have more than maximum 2 objects at a time during our game. So excellent. Everything's great. All right, now time to, we have cactuses, we have a little jumping blue square. Time to actually make this into a dinosaur. And unlike the cactuses that aren't actually animated, we're just cycling through the sprite sheet just to grab a static image for each one of these objects. Our dinosaur is going to be animated. We want the same object to use lots of different images, right, to make it seem like he's running. So the logic is going to be very, very, very similar to what we did with the cactuses. The idea that we have a sprite sheet, we're grabbing a smaller image within that sprite sheet, and we're cycling through. But in this case, we're going to just do it from our dinosaur from beginning to end. I don't know if there are any questions in the meantime. I feel like I've been rambling.
We have one question, but it's more related to organizing the code. So it's Leon. He is asking, is it bad that when I code, I only use the things needed for the current project? Example, if I want an event listener, I don't make objects and functions. I just make a little tiny function to make what I want to happen.
I don't think there's anything wrong with that whatsoever. I think that's a great approach, really. If you have a very small amount of functionality, it's kind of overkill to be creating all of these classes and subclasses and stuff, right? I just kind of got used to this because I know that what starts off as a small project in a game will end up becoming much, much bigger over time. So right now, a lot of the stuff that I'm doing probably is overkill for what we're trying to achieve, but it's laying the groundwork to allow the code to be more dynamic as the project gets more and more complex. So I don't think there's anything wrong with the way that you were describing how you approach things, but since I've gone through these problems before, I know that soon this is going to get more and more complex. So I'm just kind of making things ready for when that happens. Does that make sense?
Thank you, Christina.
No problem. Okay. So same thing over here. Let's have an image source, width, a height, and number of frames. Okay. Let's create a new image. Let's attribute the source. And now, all right, same idea. What is the width of each individual sprite? Well, it's going to be width divided by number of frames. What's the height going to be? That's going to be static. It'll always be the same. Let's remember the number of frames. That's probably going to be handy in a little bit. And similar as what we did with calculating that every 100 steps we want to do something, I'm going to use that to be able to cycle through the sprite sheet over here. So let's have this dot current frame. It's going to start off at 0. That's something that we're going to go from 0 to 1 to 2. This dot frame interval, we'll try 100. That's going to be way too slow, but we'll try 100 just for now to see. Frame counter, something we're going to increment. And let's see, do we need anything else? Current frame until we have our maximum amount of frames. Okay, I think this should be good. All right, so over here, draw image, this dot image, this dot width times by the current frame. Y-axis in our case is always going to be 0 in terms of the sprite sheet, right? And height. And now, where do we want it to be drawn on the canvas? Well, that depends on our Y and X axis. All right, so width. Okay. In our update function, frame counter plus plus, going to be incrementing that over and over and over again. Then let's do a little test. If frame counter modulus frame interval, then it's at this point that we basically want to cycle through onto the next frame. So let's do current frame plus. We also want to see if this dot current frame is equal to our maximum amount of frames. So we start at 0, then we go to 1, then we go to 2. If it's now incremented to 3, which in our case is no good because then there's nothing to draw, let's reset to 0. We also want to make sure, so I add an add condition here, because I only want to increment the frame to the next step if we've reached the amount of intervals we want, and also if current frame is still less than number of frames. So let's see, we're getting a lot of new arguments now. The image source, width, height, and the number of frames. Let's change that over here. Okay, image source resources, dino.png. The width, let's see, that's going to be the total width, is 396 by 144. A bit hard coded for now. 396, 144, and the number of frames is 3. And let's test it. Oh no. He's crazy.
Nice running dinosaur.
Yeah, a bit too fast, a bit too insane right now. All right,
and he's going through the obstacles, so it's a ghost.
Yeah, it's a ghost. So we do want to actually update him. We want to draw him after the obstacles to make sure he's on top of them. Well caught. So let's see if that. Okay, now he's on top of the obstacles. Cool. And he's running a bit too crazily. So let's see if we change. Let's see. Actually increase the counter, then the interval. No, he's still being crazy. Let's see. Oh, silly me. I'm doing a modulus, but then I'm not actually testing it for anything. There we go. All right, now it's much, much slower. Too slow, in fact, but we can visualize. We can see that pixel perfect. We're not seeing any part of the next image showing up here. It's working great. So now I will go and actually decrease the frame interval to something a bit smaller. Let's see. It's 5. How does it look? Now let's see if the jump still works. Whee! Whee! Okay. All right, cool. So we have a little running dinosaur. He jumps over the cactuses. But in actuality, we don't have a game. We just have fancy images passing from one thing to the next, because what is a game if there's no consequences, right? So all that's really left for us to finish this mini game is get a scoring system and also have a game over, right? There has to be a moment where you lose. So in order to do either one of those things, we're going to need to start to use a little collision detection. And let me run the final project. Where are you at? Ah, here you are. So we can take a look. Okay, so this is the final project. And burp, he loses. How are we going to detect a collision between our dinosaur and the cactus? So we're going to use something. It's a very simple method of collision detection. There's lots and lots and lots of different ways of detecting whether two objects have collided or not. But the one that we're going to use is called AAC. BB collision detection, which is axis aligned boundary box. You guys want to look into that more calmly later on. And this works really great when you have images that are just moving on X and Y. You don't have like rotation or anything going on. So this works great. The way that we do this is we can imagine that we have a box over our dinosaur as such. And we also have a box over our cactus, right? So what do we need to actually check for to see if these two guys have collided? Well, we need to see if this side of our dinosaur, which is the X plus the width, so this side of our dinosaur is greater than this side of the cactus, which is just the X coordinate. Now, that is not enough to see if there's a collision, right? Because he could be up here jumping, and then, you know, this part would be true, but there is not a collision. So we have to also check to see if this part of our dinosaur, which is Y plus height, is greater than this top part of the cactus, which is Y, right? Now, just those two things also aren't enough because we could be down here for some reason. And these two things would be true, and yet we're very far away from the cactus, so there isn't technically a collision. So actually we are checking all four sides. All four sides have to be true for there to be a collision. We also need to see if this side up here, which is our Y, is less than this end of the cactus, which is his Y plus height. And we also want to see if this side of our dinosaur, which is the X, is less than, it's on this side of our cactus, which is X plus width. So if all of these constraints are true, then they are within each other. They have hit, okay? So in order to do that, let's jump to our index, and I'm going to put a little detect collision function here. It's going to receive the dinosaur and an obstacle, and it's going to have one big Boolean check. That's going to check all four of these conditions. Now I have something here called padding. Let me just create that variable over here. I'll start with it equal to 0. So it's as if it's not doing anything right now, but then I'll explain why I added the padding eventually. But let's just see if our detect collision works. So let's have a Boolean game over, false. And inside our animate function, the first thing we're going to check to see, have we reached a game over state? And if we have, we leave the function. And if we leave the function, then we're not going to call request animation frame. So it's not going to call this function again in the future. So it's over. Basically, everything's going to freeze. It's going to be stuck, which is cool. At what point do we realize there is a game over? Well, let's see. Let's see when we ask all of our objects to do something. Our objects are obstacles. Okay. We ask all of our objects to do something. Okay, we'll have them update actually first, and then we'll do a little check. All right, you've updated. So let's see. Has there been a collision between you and the dinosaur? And if the answer is yes, well, game over, man. Game over. Okay. Let's see if this logic is working. All right, and they've stopped. Now, it looks like they're barely touching each other, right? This is for two reasons. One is I decided to draw white pixels around my assets for some reason. So whilst it looks like the image ends here, it doesn't. It's actually ending here, right? And also then if we draw the boxes around these guys, we can see that they have in fact made a collision. Even though there's all this white space over here, it is a big rectangle that we're talking about. So yeah, there actually is a collision. And this is due to the fact that this kind of collision detection is really, really so simple. That's just one of the issues that we're going to have with this. So as a semi-workaround, just so I can continue using this kind of collision detection, which is pretty simple, I created this little padding, which is kind of like a little leeway. I'm going to give it 20 pixels. So I'm going to allow you to get 20 pixels closer to the cactus just to make things a little bit easier, not seem super unfair to the person that's playing this game. So now we'll see. I won't jump. Let's just see if he gets a little bit closer. Okay, so now this seems a little bit more fair, right? Okay, that was, a terrible jump on my part. We might need to increase the speed of the jump if we want to make these big cactuses. Ah! Again, this seems really unfair, right? It seems like he's way off, but it's just because of the fact that this is one big box and this is another big box. There are millions of other kinds of collision detection algorithms if you guys want to look into it and see if there's anything cooler, but I think this is a good one to start off with. Okay, so we have a game over. And now we need some points, right? So if I finally make it over this big cactus, I want it to feel good. Now with the canvas element, you can actually do text, but I mean, honestly, it's kind of ugly. It's really extensive, the method calls. You kind of have to say, I want to start writing a text from point A to point B. Honestly, I think it's a lot easier if you just use your text elements by doing HTML and CSS. So that's what I'm going to do in my HTML file.
And I think that answers one of the question that we have in the Q&A. So Leon is asking, is Canvas a must when we are making a game, or can we just use viewports? Example, I made at the past a rock, paper, scissors game and a hangman game using viewport and CSS3 with JavaScript, but without Canvas.
Yeah, you can make simple games with CSS as well. It's just with Canvas, you can make smoother animations, I suppose. You can work more with images, but Canvas isn't a must. I think it's fun.
Thank you, Christina.
Right. So let's add here some CSS, some HTML elements. Let's do score, and high score. Also, in regards to game making, there are a lot of really cool frameworks that are now available, like Phaser, which is a framework that's built totally on top of the Canvas API. So whilst the Canvas API itself is pretty simple, these other frameworks that people have been making kind of encapsulate a lot of this and add a lot more. So you don't have to create the logic for gravity yourself. You don't have to create the logic for collision detection yourself. You don't have to create the logic for physics yourself, because these frameworks do that using this under the hood. So it's also a cool avenue if you want to explore that a little bit more and get a little bit more serious about game development. I think that's a good thing to look into. Imagine CSS gaming is a little bit more fiddly. Okay. So here we're going to have our score and our high score elements. And I just have a little bit of CSS to get this custom pixel font. And then I'm just using some relative positioning to push them on top of the canvas. And there we go. So now I'm going to grab these elements inside my JavaScript. Let's get the score document, get element by ID, score, high score document. Okay. Let's create a scoreboard. Score 0, high score, also starting off at 0. And when are we going to score something? Well, it's going to be at the moment that we're able to jump over the cactus is when we should get some points. So I'm going to pass into the update function of my obstacles the scoreboard and also a reference to my dino. And all they're going to do in their update function is they're going to see, all right, if my x plus my width, so the entirety of my little image, is less than, so I'm more to the left than the player is right now. Oops, let's get scoreboard here, dino here. What does that mean? Well, if he's made it past me completely and this method has been called, then it means the game isn't over yet. So clearly he's got a point. Awesome. So I'm just going to grab scoreboard, score, and add 10 to it. Okay. Now let's see real quick if that works. I noticed there's something going on over there. Let's up here, right after this, score inner HTML is going to be equal to our score is scoreboard score. Okay. Oh, what's wrong? Oh, I think when I messed up writing dino here, it automatically imported. Didn't want that. No, thank you. Okay, now let's see. Ugh, gotta change the the jumping height, otherwise we're never gonna make it. Blah, no. All right. Where is? Let's make the speed of this jump. Okay, thank you, game, for giving me a freebie. All right, now, if you guys notice, the score is actually incrementing 20 by 20, and that's because the update function is being called whilst the cactus is still on the screen. So in order to make it so he definitely only scores 10 points per object, what I'm going to do is add a Boolean, false. At the beginning, you haven't scored. And then you say, if you've made it past me and haven't scored yet, get your point. And we've scored. Okay, finally, man, this is awful. I'm terrible at this game. Finally, we're going to give a high score, and all I'm going to use is the local storage of the browser to do this. Keep it simple. So in our init function, when it's first called, let's say our scoreboard high score is going to be equal to local storage, get item, whatever is associated to dino score. We'll do a little check first because the very first time that this runs, there isn't going to be a high score yet. So we'll just see, okay, so if there is no high score, then scoreboard, well, local storage, set item, dino score, starts off at 0, scoreboard, high score is also equal to 0, and let's also grab the inner HTML. High score is whatever is equal to the high score that we grabbed earlier. And finally, all that we need to do is I'm just going to create one tiny little endgame function. And I'm going to hide that game over Boolean trigger to true in here. And what I'm going to do is when the game is over, I want to check to see, did the score that you managed to do this round, is it better than the previous high score? So we're just going to check to see if your score is better than the current high score, then let's say local storage, set item, dino score is going to be scoreboard.score. And let me just change the inner HTML to reflect that new high score, just so you can bathe in your success when the game is over. Scoreboard.score. And also I'm just going to have I'm going to replace whatever is on the screen on the score with game over. Let's see. Call that here. Check to see if it's working. Now I have a much higher score because I am not as bad as I'm pretending I am. Oh no, but this was not supposed to be here. But oh no, let's see. But yeah, I have a score already because I've been using this dino score to test this earlier. How's that showing up over here? Game over, score. I'm being silly. What am I doing? The score is game over. Oh, and then I'm saying, of course. Okay. Now let's see. New. Now what's stored in the local storage is the wrong thing. Let's just reset that. I'll lose my progress. So sad. Okay. I got to make at least one character so that we could see this.
This is harder than writing the code itself.
Yeah. But okay. I still got this game over in the wrong area. Let me see. What am I doing wrong here? I'm doing something silly, aren't I? Of course. I don't want this. I want to have this happen afterwards. Okay, so if my score is greater than high score, then we'll set the item to the new score. We'll change the high score to say we don't need this because it's going to be the same as the scoreboard score. I was doing the game over in the wrong area. Then we change this value to say game over. And now local storage. Set item, dino score. Okay, finally. One jump. What? Yay! What? Yay! What? And now when the game over, high score updates. And if we refresh, we'll have our little high score stored from the last game session. Okay, so now how am I going to share this with all my friends, you ask? This amazing, incredible game? Well, it's actually very, very easy. Let's find where it is, for instance, on my computer. Okay, so in my case, I have a Mac, but independent of what kind of system you use, And also this depends on where you're doing it uploading to. I'm going to show you how you can upload it to a place called itch.io. It's a site. You can create a free account. They constantly do game jams, which is like you have like a weekend to make a game, you make a team, you start from scratch. It's a lot of fun. And you can also publish indie games. You can make money for your indie games. You can buy indie games on there. And the way that you can upload any project is you're going to take your entire folder, compress it into a zip, because that's what they're expecting you to upload. Then on the site, I'm giving one example here, but you could use any kind of site that publishes games. You're going to have, in this case, on this site, once you've created a profile, you go have an upload new project. So you can go to upload new project. Then you will have basically like a lot of configurable stuff. You can configure whether you want to get paid or not, but obviously if you're going to make a game that you're going to get paid off, you can't be cloning other people's games or using copyrighted music or anything like that. You can add a little cover image. That's going to be an image that's going to show up when you link your game to other people. So I'm just going to grab, let's see, images, screen grab. Beautiful. Totally unique game, not the ripoff. Cool. Now you have a unique URL to your game. And then you say, on this case, what kind of project are you going to have? My case is going to be an HTML game. And then you can upload the file. It needs to be a zip. So let's grab this zip. And then depending on what kind of game it is, it could be like an executable game if you're using something like Unity or whatever to make it. And then you'd say what kind of platform it's meant to be. In our case, it runs in the browser, so literally anyone can play it as long as they have access to the internet. So we'll say this file will be played in the browser. We'll check that. It's going to be embedded in the page, and then you just say what the dimensions are. Let's see. Let's try this out. You can write some description about what your game is. And at the beginning, it starts as a draft, then you can make it public, or you can make it restricted so that it's not publicly searchable, but you can link people to your game if you want. Save and view. Run the game. And let's see. No! Damn you. It's much harder to play than I thought. Okay, but there you go. And this would be something that once I made public, I could share very easily with anyone. It took 2 minutes to upload to the site. You just have to turn it into a zip file. And that's it. You don't need to have any special server to show this. You don't need to have a site set up. You can just create a game in 2 hours, and now you have something ready to share with people. Pretty cool.
It's amazing.
Yeah. What would I do now to fix this game or to add some extra things to it? I would look at how the original one is, since we're doing a clone, right? And I would think, okay, what other features are in the original one that's missing from my one? So maybe some objects that fly in the screen and you have to crouch down. For that, I'll have to create a new sprite sheet where the dinosaur crouches. There's maybe some things that we're doing in our game logic that's not super optimal. For instance, this idea of me painting over the entire screen because I don't want you to notice his little feet moving is not the most optimal way of doing this sort of thing. What you would probably rather do is only clear the portion of the canvas that is different, and everything else is the same. You want to remain the same. So yeah, I would refactor this. I think about maybe these kind of performance optimal things. There's something else that I think would be cool if you guys want to look into it, which is you don't want to be doing the update of your animations based on a fixed value inside of request animation frame, because the amount of times that this is called is going to depend on the kind of machine and browser that the individual has. And the idea is you want him to be moving at the exact same speed independently of the kind of browser or machine that the person has. So in order to do that, you would need to look into something that's called delta time, where you want to know how much time has passed since the last time this function was called, and you want to use that to be able to calculate your updates. But I'm just like throwing things out here, like how would I approach maybe refactoring this or improving this going forward? But yeah, that's it. That's what I have to talk to you guys about. I hope it wasn't too much.
It was amazing, Christina. It was definitely worth standing for the period you were coding.
I'm sorry.
No, it's okay. I really enjoyed developing the game. And actually, we have one question from Harry. Let me just find it here. All right. So Harry is asking, he has many questions. So what technologies would you recommend to a beginner at the moment regarding games or projects for the web, both for 2D and 3D graphics / animations?
Okay, so like now, currently, I like to make mini games. It's not something that I do professionally, but something that I like to do on the side. And what I use to do mini games and to participate in these kind of game jams is actually something called Unity. And Unity is it's really great because it's one of the most popular game engines. It's not even a framework; it's an engine, meaning that it does a lot of things for you, like calculating gravity and collision detection. But it also is it's quite a big thing. It's kind of overwhelming to get started in at first. And I honestly think when you're starting off and you're learning programming and you want to kind of improve your skills with algorithms and learning all this kind of stuff, using something as basic as Canvas for me was something really, really cool because, for instance, I'm not very good at math. And there's a lot of mathematics and algorithms when it comes to creating games. So this kind of forced me to really think, okay, how does friction work? How does gravity work? How do I make a movement that looks like an arc? So I think it's actually really good to follow some tutorials about HTML5 Canvas, for instance, in the beginning. And then once you're more comfortable with how these kind of things work under the hood, I think using something like Unity would be cool. Unity also works for both 2D and 3D.
That's great. And the second question, is it worth investing time in order to profit from this knowledge and skill somehow in the future? If yes, with a web developer in mind, in what ways? So I think we already saw that you can make it payable on itch.io. So I'll let you answer the question, Christina.
Mm-hmm. Yeah, yeah, you can make. Yeah, I mean, this has been very focused on gaming stuff, and obviously, gaming as a whole is not necessarily a career you want to get into for the money, because it's more a career of passion. But if that's something that you're interested in, I think it's worth investing all the time into learning this kind of stuff. It's incredibly fun. It's a lot of fun to do this. And of course, you can make some money on the side.
Great. And the third question, what if someone decides to convert a game idea, let's say a board game, card game, into a PC game at a later time? We'd have to rewrite the code from scratch with another language, right? So I think he's asking
if that's viable, if it's possible. Yeah. Okay. Well, I actually think that's a really good exercise, and there's actually been quite a lot of PC conversions of board games, and I think I mean, it's a lot of the same logic is there, right? You got to think of the game rules. What is the incentive of winning? What's the incentive of how do you lose? I think cloning something that pre-exists is a really good way to learn, because one of the hardest parts in creating a game is game design, thinking about what makes a game fun or not. And if you clone something that already exists, that part of the equation has already been thought out. Whether that be a PC game or a board game, I think it's a really good mental exercise to do. I don't know if that answered the
Cool.
question, but
And the last question is, any comments regarding 3.js?
no, I don't.
All right. So thank you very much, Christina. Let me check just the chat. And so we have Syrian saying, really great, hard but outstanding. Thanks for sharing.
Okay.
Peggy is saying, thank you, Christina. It was incredible and very interesting. I totally agree.
Awesome, awesome.
Actually, everyone is pretty amazed with what we achieved today. Ahmed is saying, it looks hard to be honest, but with practice we can manage to do it. Thank you for this very useful session. I learned a lot from you today, so thank you.
Awesome, awesome. Great, great, great. I'd love to hear it. And all of the stuff that I've been doing is going to be on a Git repository, okay? So you guys will be able to look at it a lot more calmly. You'll have the assets that I made so you can also recreate it. And I'll also leave links to the demos that I showed in the beginning.
Definitely. So by tomorrow, it will be the recording will be uploaded on our YouTube channel, so SHA Hackers Academy, and you will have the repo link over there, so you can go play around with the code and so on.
Awesome.
Yeah. So thank you again, Christina, for your time and your passion. It was really amazing. I loved it, and thank you everyone for joining us today. And see you soon, everyone.
All right. Bye.
Thank you. Bye-bye.